So we've been working with radical expressions so far, where you're kind of just working with one side of an equation. You're not worried about actually solving for what value your variable could be. We want to be able to solve the equations as well, not just an expression. We've done a little bit of work on how to handle radical expressions, so let's jump into how to handle radical equations. We're going to be solving for x, and along the way, there's a little mishap in kind of how it's done, and I'll explain that later. And the problem, we call it an extraneous root. There's one of the roots doesn't necessarily work, and we'll show you when we get there and why that happens to be that way. So here's a radical expression, a radical equation. So we need to state the restrictions of x for this first, and then we're going to solve for x. So we know that underneath here, it can't be less than 0, because if it's less than 0, then you're doing a square root of a negative number, and we know that is an imaginary number. So to find out what doesn't work under there, first we need to find out what would make that less than 0. So you solve this equation, inequality, just doing regular algebra. So you're going to add 1 to both sides. 2x can't be less than 1. And divide both sides by 2. And we find that x cannot be less than 1/2. So if x was 0, for example, 2 times 0 is 0, minus 1 is -1, and then we'd have a negative root, and that's no good. So we've stated the restrictions. Our x value cannot be anything less than that. So let's solve this like it was a regular equation, doing algebra and our idea of doing opposite operations, until we're down to x equals something. So first things first, we want to isolate our x. So the reverse of BEDMAS is the strategy. You want to get rid of any addition and subtraction first. Let's get rid of this 5. So we'll take 5 away from both sides, and we end up with root 2x minus 1 equals 5. Taking 5 away from both sides, this would turn into 7. To get rid of the square root now, we are going to square both sides. So square the square root of 2x minus 1 and 7. So squaring both sides. When we do that, the square and square root cancel out. You're left with 2x minus 1 equals 49. Next, we're going to get rid of this subtraction by adding 1 to both sides. So 2x equals 50. And then divide both sides by 2 to get x. 50 divided by 2 is 25. So we find that x is equal to 25 in this case. The next one, find all the restrictions for y in the equation. -8 plus root of 3y over 5 equals 2, -2. We need to make sure it's a real number. In other words, we need to find out what would make this less than 0. And then we solve the equation. So we want to find out what would make y, what would make what's underneath the root less than 0. So solving this, we want to isolate our y. We can divide by 3 or multiply by 5 first. Doesn't matter which. For funsies, let's divide both sides by 3 first, because most people get rid of what's underneath. It'll work out to be the exact same. I'll show you. So if we divided both sides by 3, then we would have 3y over, or we would just y now. No, I had that right. 3y over 15 is, and then 0 divided by 3 is still 0. 3 over 15, that simplifies, this can simplify to being 5. And then we have y over 5 is less than 0. Multiply both sides by 5. 0 divided by 5, or 0 times 5 is 0 still. So y can't be less than 0. Let's do it the other way. It's simpler. I just wanted to show you that when you have a fraction, it works both ways. Let's multiply both sides by 5 first. This is the route most people would take. I do like doing math in weird ways because I'm like that. So multiply both sides by 5 and you would have 3y is less than 0. 0 times 5 is 0. And then divide both sides by 3. 0 divided by 3 is 0. So y can't be less than 0. You can try any value in there you want that's less than 0. Let's say negative 1. 3 times negative 1 is negative 3. Negative 3 divided by 5 is negative 0.6. And that's no good. Now let's solve it. Let's find out what our y equals. So add 8 to both sides, and you'll have on the left side 3y over 5. If you add 8 to negative 2, you'll have 6. At this point, we need to square both sides. To get rid of that square root. And we'll have 3y over 5 is equal to 36. Multiply both sides by 5 to find out what 3y is. 36 times 5 would be 150 and 30, so 180. And divide both sides by 3 to find that y is equal to 30. Let's do one where we have to deal with the extraneous root. So the extraneous root is going to be when we try and solve this at the end using the values for x that we find, we'll find out that the x doesn't work for one of the two equations. So the first thing we're going to do, have a look at what's underneath the root and make sure we identify what can't be x. So find out what 5 minus x, what would make 5 minus x less than 0. So if we were to solve this, we're going to subtract 5 from both sides, so negative x less than negative 5. And to turn this into positive x, we're going to multiply both sides by negative 1, multiply the whole equation by negative 1, and you have negative x less than negative 5. Remember that when you're multiplying something by negative 1, you are going to flip the sign of your inequality. So negative 1 times negative x is positive x. You flip the inequality, and then negative 1 times negative 5 is positive 5. So x cannot be greater than 5. So let's just imagine like a 6 if we put in 6 for x. So 5 minus 6 is negative 1. That's no good. So x cannot be anything greater than 5. Let's solve this. It's a bit of a haul here, so try and make sure there's lots of space. So x minus the root of 5 minus x equals negative 7. So let's start by subtracting x from both sides. So we are going to, we want to be able to get rid of this square root, so we can, a couple of ways. You can either get the left side to be a perfect square, get the left side to just be the square root on that side and bring everything over to the other side, or you can square root everything, or square everything from the start. But let's bring that x over to the other side. So subtract x from both sides, and you'll have negative root 5 minus x equals negative 7 minus x. To get rid of this negative, we need to multiply everything by negative 1. So multiply the whole equation by negative 1. And 5 minus x equals negative 7 minus x. Remember, the net result of multiplying something by negative 1 is everything changes signs, all of your terms. So negative 1 times negative root 5 over x becomes positive root 5 over x, root 5 minus x, sorry. And negative 1 times negative 7 is positive 7. Negative 1 times negative x is positive x. Now, to get rid of this square root, we're going to square both sides. So squaring 5 minus x equals 7 plus x squared. Make sure you're not, like when you're squaring both sides, make sure that you're not just squaring the 7 and squaring the x. You're squaring 7 plus x. So, square it, and you'll have 5 minus x equals x plus 7 times x plus 7. Going to recognize some of our quadratic stuff here. So let's solve this out. So 5 minus x is equal to x times x is x squared. X times 7 is 7x. 7 times x is also 7x. And 7 times 7 is 49. So you'll notice that we have our trinomial over here when we rewrite this out by combining this together. We've got x plus 14 plus 49. Notice the trinomial, and remember that the best way to solve our trinomials is through the quadratic equation. So we're going to do a quadratic equation, but to use the quadratic equation you need 0 equals your trinomial. So let's bring these two to the other side and make the left side equal to 0, and we'll have our quadratic, and then we can use the quadratic equation to find out our two values for x. So take 5 away from both sides, and you'll have negative x is equal to x squared plus 14x, and 49 minus 5 is 44. Add x to both sides to make this equal to 0. And you'll have x squared, 0 equals x squared plus 15x plus 44. And from here we're going to employ our quadratic equation. So x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. Substitute in our values, and we'll get negative 15 plus minus square root of negative 15 squared minus 4 times 1 times 44 all over 2 times 1. Let's simplify what's underneath here. So x is equal to negative 15 plus minus 15 squared is 225. 4 times 1 times 44. 4 times 1 is 4. 4 times 40 is 160. 4 times 4 is 16. So 4 times 44 is 176. So under here, square root of 225 minus 176 all over 2. Let's keep going. So x equals 15, negative 15 plus minus root 225 minus or 225 minus 176 is 49. So root 49 over 2, and we'll finally be able to have our answer here. So root 49 is 7 over 2. So let's find our two values of x. So x is going to equal negative 15 plus 7 over 2. Negative 15 plus 7 would be 8, negative 8. Negative 8 divided by 2, negative 4. So that's one of our x's. There is another x value though. If we subtract the 7, so x equals negative 15 minus 7 over 2. So negative 15 minus 7 would be negative 22. And then negative 22 divided by 2 will be negative 11. So there's our two solutions. X is equal to negative 4 and x is equal to negative 11. One of those won't work when we go to verify. So you take your value to verify, remember, you take your values for x and you put them into your original equation. So let's first try the negative 4. So we'll substitute in negative 4 for our x's. So negative 4 minus the square root of 5 minus negative 4. And that should equal negative 7. So underneath here, 5 minus negative 4 would be 9, positive 9. The square root of positive 9 is 3. So negative 4 minus 3 equals negative 7, and negative 4 minus 3 is indeed negative 7. So that one works. Let's try the next one. Let's substitute in negative 11 for our x's. So negative 11, 5 minus negative 11 is equal to negative 7. So negative 11 minus 5 minus negative 11 is square root of 16. So square root of 16 is 4 and equals negative 7. Negative 11 minus 4 is negative 15. And that does not equal negative 7. So in this case, the negative 11 for x is what we call extraneous. And that's because of something we did at the start. In fact, if you were to actually take this quadratic and you were to put those two numbers in there, if you were to put negative 4 and negative 11 into this quadratic, it would be true. Negative 4 and negative 11 both work for this quadratic. So somewhere in between our quadratic, it's not that our quadratic equation is wrong. You can try that on your own time if you wanted. If you want to try substituting negative 4 and negative 11 into the x's here, you'll notice that both the equations would equal 0. So something happens along the way here. Why do we go from, how do we go from something that works, and if you're working backwards, how do we end up with something that doesn't work for one of the two? And the answer is actually right here. When we're dealing with this square root, remember there's the plus minus that you're supposed to work with square roots? But we kind of skip over that at this point to solve for it, and with good reason, because and it's called the principal square root, where we're just looking for what the positive outcome of this would be. Because if you didn't, imagine what mess you would have after this point if you were trying to work with the plus minus of both sides. You would end up with a whole bunch of plus minuses down here, and then in your quadratic equation you would be plus minuses everywhere, and it would be just a giant mess of something to work through. So at this point here, when we're trying to solve for x with radical equations, we tend to just look for the principal root. we tend to just look for the positive outcome here. And then when we're solving a quadratic, this is different because at this point we are going to we are going to utilize the plus minus to solve this part properly. But when you're solving radical equations, we gloss over the plus minus. Now, if you went through all of that, you would probably find something that works out. But to keep it a little bit cleaner and nice and easy, when we deal with this square root, we don't worry about the plus minus, just the plus side of it, the principal root. So in the end, after all that work, this quadratic will find us one value that is extraneous because we didn't work with the negative. Remember, we didn't work with the negative side of this. We did work with the positive side. So of course our this root is going to work out, whereas the other one ends up not. So one for you guys to try: state your restrictions and then solve the radical equation. In the end, verify both the values in this original equation and see if it works out for both of them. If it doesn't, one of the roots is extraneous. So pause it, give it a try, and I'm going to solve it now. So 2x plus 3, the square root of 2x plus 3, that needs to be a positive value. It needs to be greater than 0. So let's find out what would make this less than 0. So 2x plus 3, we want to find out what would make that less than 0. So subtract 3 from both sides, and 2x less than negative 3. Divide both sides by 2, and x cannot be less than negative 3 over 2. If it were, you'd have a 0. All right, so there's our restrictions. Let's solve the radical equation. So x minus root 2x plus 3 equals 6. Bring the x over to the other side, and we'll have negative root 2x plus 3 equals 6 minus x. Multiply everything by negative 1, and you'll get root 2x plus 3 is equal to positive x minus 6. Now we're going to square both sides, and we'll be left with 2x plus 3 is equal to x minus 6 squared. Let's expand this out, and we'll have a trinomial. So 2x plus 3 is equal to x minus 6 times x minus 6. And so 2x plus 3 is equal to x times x is x squared, x times negative 6 is negative 6x. Negative 6 times x is negative 6 more x, and then negative 6 times negative 6 is 36. Let's work with our quadratic equation. We're going to need 0 equals our trinomial. So we're going to bring these other two over to the other side. Let's bring the 3 over. So we're going to subtract 3 from both sides. So 2x equals, and then we can put these two 6's together. Oh, sorry, this is supposed to be x squared, if you didn't do that. Negative 6 times negative 6, or sorry, plus, negative 6 minus 6 more is negative 12x. And then we're subtracting 3 from both sides, so plus 33. Divide both sides by 2, and you'll have, or sorry, we're not solving for x on the left. We're making this equal to 0. Subtract 2x from both sides, and we'll have 0 equals x squared. If you take 2x away from negative 12x, you'll have negative 14x. and then plus 33. Alright, let's use the quadratic equation to find our two values for x. And then we'll find out which one's extraneous. So, negative b plus minus square root of negative 14 squared minus, oh, sorry, let's jump right to it. So, negative of negative 14 plus minus the square root of negative 14 squared minus 4 times 1 times 33 all over 2 times 1. Negative of negative is positive, so 14 plus minus negative 14 squared is 196, square root of 196. 4 times 1 is 4, 4 times 33 be negative 132, all over 2. So we got to solve what's underneath the radical there. So 14 plus minus 196 minus 132 would be 64. And then that's all over 2. Square root of 64 is 8. So our two values, I forgot something up here. This is x equals. So let's just shove that over a smidge. So x equals 14 plus 8 over 2 and 14 minus 8 over 2. So those are two values for x. So 14 plus 8 is 22. 22 divided by 2 is 11. 14 minus 8 is 6. 6 divided by 2 is 3. So let's substitute these into original equation to verify and see if either of them are extraneous. So here's our two x's. For the equation, x minus root 2x plus 3 equals 6. Let's substitute in first the 11. So 11 minus root 2 times 11 plus 3 is equal to 6. So 11 underneath the root 2 times 11 is 22 plus 3 is 25. So minus square root 25 equals 6. And the square root of 25 is 5. So minus 5 equals 6. 11 minus 5 does in fact work. So next one, let's do 3. So 3 minus root 2 times 3 plus 3. Let's see if that equals to 6. So 2 times 3 is 6, plus 3 is 9, so 3 minus 9 is equal to 6. 3 minus 9 is negative 6. Negative 6 certainly doesn't equal 6. So this one doesn't work. So this is extraneous. that's all for the first part of working with radical equations. Thanks. See you next time.